Alright, grade 7. So this week we're looking at the law of conservation of energy. There's just going to be a brief video that ties everything in for you. So we're going to start with natural sciences and just chat about this quickly. And then I'll just explain what's required from you for the rest of the week for social sciences and technology. Okay, so you guys are doing extremely well, especially under the circumstances. I know it's a bit disruptive. You're away from school and then back at school, but we do the best that we can. And as I say, I'm very proud of you guys. You're becoming very matured and very diligent young adults. All right, so just keep your heads down and work as best as you can, as you have been doing. All right, so for natural sciences this week, the most important thing, we're looking at the law of conservation of energy. So we've spoken about potential and kinetic energy. You'll know now that potential energy is stored energy, either in the form of a fuel, a stretched elastic band, etc. All right, and kinetic energy, as soon as it is moving energy, as soon as that potential energy is converted into moving energy. All right, so what we're focusing on today is the law of conservation of energy. You need to study this definition pretty much off by heart, but also know how to explain it. So when we read it, it says here that energy cannot be created or destroyed. It can only be transformed from one form into another. Okay, so what does this mean? This means that there's always energy available in some form, but we need to either tap in or harness that energy into doing work for us. Okay, so, and I'll give you a few examples. Once we've tapped into that energy source, usually a potential energy source, we can now transform it into something else. And those it can be transformed into 4 different things. And we spoke about these 4 outputs. It's either going to be heat, light, sound, or movement. Okay, so you'll see in the video description for this week, I've given you an example of that desk ornament that you've probably seen before, where it has steel ball bearings, all right, attached to either fishing line or steel wire or whatever it may be. But you'll see when we lift up the first ball bearing, we are now giving it potential energy. Okay, so remember, it has not now moved, we've just lifted it up into the air. As soon as we release the steel ball bearing, so theoretically it would be here, as soon as we release it, it'll go back and smack into the next ball bearing, transferring the energy, all right, that we've given it. So it'll transfer it from one ball bearing to the next. And then right at the end, this ball bearing will then lift up and then it'll return back, and it'll continue until it eventually stops. Now, the reason why it doesn't continue forever is because energy is being lost through this process. So how's it being lost? We know that the one output, as soon as we release the ball bearing, is movement, but as soon as it smacks into the next ball bearing, we hear a sound, all right? So that means some of that energy dissipates in the form of sound. Okay, as well as there's a slight bit of friction, and friction we know will cause heat. So we lose the energy into those 2 forms, either in the form of sound or the little bit of friction, and that is heat. And then this process will continue until all the energy has been lost through sound and heat, and therefore the movement will eventually stop. So that means we can see that there's been a transfer of energy throughout our system over here. So that's what the law of conservation of energy stipulates, is that this energy was not destroyed. It was just merely transferred into a different form, right, and then dissipated through the system. So that is the law of conservation of energy. The video in the description will go a bit more in detail with this that you can watch, all right, but this is just tying it all in. I'll again leave you to read through page 110, and then we'll go through the energy transfer within systems and being able to identify the system. All right, so where did the potential energy come from? Where did it turn into kinetic energy? All right, and then later in the term, we'll look at efficiency and how energy is lost in a system. So just to give an example of efficiency, if we have a light bulb, the sole purpose is we want light. And if it's giving off any form of heat or maybe a buzzing sound, that means that the sound that we're hearing in the form of the buzz or the heat that we're seeing coming or feeling from the light bulb is wasted energy, so therefore it makes that light bulb less efficient. Okay, but that only comes a bit later in the term. So this is natural sciences. The next thing we'll talk about is social sciences. You're going to be looking at, in the geography side of social sciences, you'll look at scientific developments. So scientific developments tie into a few things, genetically modified food being one of them, advanced medication and healthcare, as well as surgical practices. So the improvement in science and technology has helped population growth immensely. That's pretty much what you're reading through this week. There's no formal activity for geography. It's just understanding those concepts and how science has helped with population growth. Okay, on the other side for history, you have 2 things. One, you should be preparing your speech. I've left a rubric attached in the description for you. So just find that attachment so you can see where you're getting your marks. Please note that social sciences, speech, for history, I'm not going to focus too much on posture and eye contact, etc. It's more the content and the relevance and delivering that speech in a clear manner for me that I'm able to understand it. Right, so you have to pretend that you're teaching someone about the slave trade that knows nothing about the transatlantic slave trade. This one helps you revise the transatlantic slave trade. And for those of you that are presenting it in class next week, Friday, it also helps the rest of the class. So obviously going to hear more about the speeches and revise a bit more about the transatlantic slave trade. For those of you not comfortable to do it in class, please, I need it sent to me in the form of a link before Friday or latest Friday, so I can at least mark that speech. Okay, and then the history content for this week as well that you're going to be looking at is just the Free Burgers and the French Huguenots. Just a bit of not revision, but a bit more research on those two, just telling me what the difference was between the two sets of farmers and also what they farmed. To give you a bit of insight, we know that the Freeburgers were VOC, so they came from Holland, but they wanted their independence. So you'll do a bit more research there and you'll see what type of farming they done. Right, and then secondly, the French Huguenots, we know that they were persecuted for their religion in France, so they had to flee. They came to Southern Africa, but they farmed a totally different crop, and it also led to a lot of, well, didn't lead to, but it makes Western Cape very famous for a certain type of farming. And I want you to be researching that, please, and you're going to put that down for me. And then lastly, technology is complex machinery, where you're going to just look at the 6 different types. This is important. It's going to be going through into grade 8 and 9 technology, but you're going to be just looking at the wedge, the ramp, screw, lever, pulley system, and so on. I've left a video that describes them very nicely for you in the description, so you can go and look at that. All right, and you'll have a better idea. So you're just going to revise that in your technology books. You're going to draw the 6 different types of simple machinery and give me a brief description of each and how it maybe helps you to do work. All right, grade 7. So as I said, you're doing extremely well. Hopefully I'll see majority of you next week back in class, and then we can again go through a lot of this stuff and revise. If you have any questions, please feel free to ask me. You can email me or just note them down, keep them for when we're back in class. You can ask me and I'll help you with all the work. We are almost done with term 3's content, so we should be done with it within the next 2 or 3 weeks, leaving that last bit of the 3rd term to move on to 4th term's work and get you prepared for the final exams or whatever form of testing it's going to be. But at least you'll have all the content down. If you have any questions, you can ask me. We'll have plenty of time to revise in the 4th term because you'll almost be done with the content. Okay, grade 7. So keep well, look after yourselves, please. I hope to see you all again next week.